This is a quick video to go over the practice problems to homework 5-2 for Chem 1. We're going to be drawing Lewis structures for each of the three compounds on here. We're going to walk through the rules one at a time. The first rule is to add up the number of valence electrons available by each of the atoms in the compound. That can be found by the family that each element belongs to. Hydrogen is in family 1, so it has 1 valence electron. And chlorine is in a halogen, it's in family 17. It has 7 valence electrons for a total of 8. Oxygen's in family 16, it has 6 valence electrons, plus there are 2 fluorines, and each of the fluorines are halogens in family 17, just like chlorine was. So they have 7 valence electrons. 7 times 2 is 14, plus 6 is 20. And last but not least, phosphorus is in family 15. That's going to give us 5 valence electrons. There are 4 oxygens. And each of the oxygens have 6 valence electrons, just like they did in the previous example. But this time we have a charge. We have a -3 charge. Now electrons are negative, and so a -3 charge means that we have gained 3 additional electrons, so we'll add that into the total. 6 times 4 is 24. 24 plus 5 is 29. 29 plus 3 is 32. That's step 1. Step 2, we want to connect everything to the central atom with at least a single bond. In our first example, HCl, we only have 2 atoms, and so we will simply connect them with a single bond. Here on the OF2, generally the element they list first is the central atom. It should also be the least electronegative. And finally with PO4, P in the middle, and 4 oxygens around it. Atoms bond to create a stable set of valence electrons, and the most stable family on the periodic table is the noble gases. The noble gases each have 8 valence electrons, and so we're going to take all the elements on here and put dots around them until they have 8 electrons represented. Hydrogen is the one exception. Hydrogen wants to be like the noble gas helium, which only has 2 electrons, and hydrogen is already sharing 2 electrons in this bond right here. Chlorine's also sharing 2, and so it needs another 1, 2, 3, 4, 5, 6. A nice way to think about this is picture the elemental symbol having 4 sides, and make sure there's electrons on all 4 sides. So same thing here. The fluorine is sharing 2 of the oxygen, so it needs 6 on its own. The oxygen sharing 2 on each side, so it just needs 4 more, top and bottom. And this fluorine is sharing 2. Similar thing over here with phosphate. The phosphorus already has 8 electrons on it with the 4 bonds it's sharing with the oxygens, but the oxygens need dots. Takes a moment to do this, especially virtually on this machine. All right. Next step, we want to add up all the electrons on the drawing and compare it to the number of electrons available. If the numbers match, then single bonding is the right solution. If the numbers don't match, we're going to have to look at double and triple bonding, which will be part of tomorrow's lesson. All right, so counting by 2s or skip counting is really helpful. Around the chlorine, we have 2, 4, 6, and then 2 in the bond for a total of 8. So there's 8 electrons here, 8 is the right number, this should be the right structure. So HCl, sometimes called hydrochloric acid, should have a single bond in it. Here we've got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Again, 20 is the number we expect, matches the number we predicted up top, and so single bonding works. And on the final one, and the hardest thing to do sometimes is to count without accidentally skipping some or counting some twice. So we want to find a good pattern for that. I'm going to start here at the left and count the dots first. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. And then I'll count the bonds. They're also worth 2 each. 26, 28, 30, 32. All right, that is the right number. And that should be the case for today's assignment, that single bonding is often the right choice. Last step, if you do have a polyatomic ion like we do with phosphate, I know it's an ion because of the charge on it. I just want to put that in square brackets with the -3 charge on the outside, just to remind everyone that this structure has 3 extra electrons in it. So hopefully that's a pretty straightforward set of procedures. You can review this video as often as you need to, and we'll go an extra step tomorrow looking at double and triple bonds.